Hello, am I audible?
Yes, sir.
Yeah,
Yes.
good morning all and sorry for the delay. Actually, there was some issue with one of our colleague who was about to take live session today, but anyways, I'm taking it now. Uh, so just give me 2 minutes, okay, and then we can start our session, okay? So I'll just
Good morning, sir.
very good morning. Give me a minute.
Morning, sir.
Voice is very low.
Voice is very low. Okay. Now is it fine?
Yeah, now it's fine, sir.
Okay. Yeah, I'll just share my screen. I hope my screen is visible.
Yes, sir.
Okay, fine. So I can see like 50 of us are here today. He's asking, Virendra, do you want to write something on screen? Because I'm getting this pop-up saying that you want to annotate on the screen.
No,
Okay,
sir, my phone is not doing well work.
okay, fine, it's okay. We'll manage. All right, so how was week 2?
Fine, sir.
It was easy, all of you?
Yes,
Length.
yes.
Yes, sir.
Interesting day.
Okay. So that was easy, but from now onwards, you should slowly pick up, with some little more concepts coming up in week 3 and week 4. Okay. So week 3 is slightly difficult than week 2, I would say, and week 4 is slightly difficult than week 3. Okay, so that's how it is. So you would now see basically like in week 1, what did we study was sets, relations, and functions, right? So we introduced something called functions, and then we jumped into a very small function, let's say a linear line, right? A concept of linear line, which is again a function, right? It represents a function. Now again, when you go to the next thing, it's called as an quadratic functions, and then you go with polynomial functions, and then let's say exponential functions, logarithmic functions. So this is how your next week are going to be. Okay. So now, before going quickly, I just want to ask you one question, and then we can just motivate ourselves that what we are going to do in this session. So it's just a quick question to all of you. Let's say there is a question, and there are a few graphs which I'll be drawing. Okay. So let me call this as 1. So basically, let me like this. Be like this. Okay. So now look at this graph. Okay. Could you tell me which among all these 4 represents a graph of a function?
None, sir.
None?
Not yeah, because
Okay. Okay,
every
don't give me the reason
pre
right now. Let me
yeah
take up
because
all the thing from, so some of you say none. Let's say all. Let's say 1 and 4 only, 2 and 3 only. Could somebody tell me which among the following represents the graph of a function?
first one, sir.
1 and 4.
All, sir.
All?
All.
Yeah,
Yes.
all.
Okay.
So every because this graph
Every input
represents
has.
for this graphs every pre-image has a two images.
So this is not a function you mean to say?
All I mean yeah, all 4 are not function.
All 4 are not function. Okay, so some of you said this also. What about anybody with 1 and 4 as an option?
Yes, sir.
Yes. Okay. What about 2 and 3? Why do you say 1 and 4? Because it's not touching the x-axis. Okay.
All are functions, sir.
All are functions. Okay. So now let's go with the answers. The actual answer is all are functions. All represent a functions. So I told you in the when I was just telling you a while ago that we started with our first week sets, relations, and function, and then from functions we picked up various types of functions like straight line, quadratic quadratic expression basically, or quadratic polynomial, let's say, or then we have like polynomials and then exponentials and then basically logarithmic, right? So when I told you that things, I meant like, yeah, this quadratic equations are all functions only, okay? So does this represents a quadratic polynomial or a quadratic expression or a quadratic function? This one, first one?
Yes, sir.
Yes.
Quadratic
sir.
function.
Yes. How many roots are there for this?
2 roots.
Or real roots.
Sir.
0 roots basically. There is no roots in this. So this
Imaginary root.
represents a
Because it's
quadratic.
intersecting y-axis, right, sir?
No, not
Because it
intersecting
is
y.
not
Because
intersecting to any
exactly.
point on x-axis.
Yeah, so the roots are basically roots are also called as x-intercepts. Okay, so how many x-intercepts are there for this curve?
0.
0, right? So make a note of that. So roots are basically the x-intercepts. Okay, and does this represents a quadratic functions? Answer is yes. What about this? Does this represents a quadratic function?
Yes.
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 And how many roots are there for this?
2.
Two roots.
Two roots. What about this? Does this represents a quadratic function? Yes.
Yes.
And how many roots are there?
2.
2.
Two roots.
Likewise, for this represents a quadratic function? Yes or no?
Yes.
Yes, sir.
Okay, and how many roots are there?
Zero.
0.
0.
Okay, so let me draw one more here, and then things become. Now look at this quadratic function. How many roots does this have?
Only one.
1.
2 equal roots.
Basically, you can't. Okay, fine. You can say two equal roots, but the root is significantly one. There is only one distinct root, right? So let's say this as 1. Okay, so how many roots are there? So root is 1, but with multiplicity 2, right? So we'll talk more about this. So, and look at this curve. All of these represents a parabola, and you all of us agree this represents a quadratic functions, right? Okay, so if that is the case, then how do we understand, the parabola opens upward or downward, or when do we know there are no roots, or when do we know whether this is on the left hand side, whether this, let's say, if this is your axis of symmetry, so whether this axis of symmetry is on the right side or the left side, how do we really understand this? Could you tell me where the axis of symmetry for this is? Basically somewhere here on the left hand side of the y-axis. For this, the axis of symmetry is on the right hand side. Axis of symmetry is basically a line which divides this parabola into two halves, right? So that is axis of symmetry. Look at this, for example, for this one, the axis of symmetry is on the right hand side, and for this one again, this is on the left hand side, right? All of you can see, and this is again on the right hand side. You can also have a quadratic function whose axis of symmetry is basically y-axis, right? For this, you can notice, right? The axis of symmetry is y-axis itself. Okay, so how do you know whether the axis of symmetry is on the left hand side or the right hand side, or when do you say the parabola open upwards or a downward, right? Or like these are something, and I think some of you will be knowing already these things. So well, just to give you an revision to all those who already know, and those who don't know can stay with me, like how can we actually know all these, right? So this is one concept we'll be learning. This is what it's called as, basically this comes under the graphings of a quadratic equation, quadratic functions. So how do you draw the basically the graphs of this kind of functions when it is given? Okay, so all of you okay with that? So that's the first concept.
Sir,
Yes,
a
sir.
quick question.
Yes.
So when you asked that if this is a quadratic function, he says if these graphs are quadratic functions, is the answer yes only because all of these are parabolas, or any
Yes.
graph will be a quadratic equation, or do we have any graphs which are not quadratic equations?
Not quadratic equations? Okay, so you can take some graphs like this.
Okay, so that is a linear.
Yeah, that is a linear graph. You can also think of some curves like this. This does not represent. So look at this. All these are parabola, and it is either upward, downward, left hand side, right hand side, but it is parabola. If it is a parabola, it represents a quadratic function.
Okay. Only if the graph is a parabola, it's a quadratic equation.
Okay. And we also had doubt, some of you had a doubt, okay, this does not represent a function. Then why does not it represents a function? Do we remember that when we were discussing this, like function, so function is from R to R, right? Let's say this function is from R to R, and this is your R, basically all real to all real, right? So look at this part. For every value of x, now let's say if I take -4 and 4, or let me not take this big value, but let me take as, and let's say our function f of x is x squared. Okay, so now look at this. If I take it 1 and -1, what is the output? 1.
1.
Right? Now look at this. Does this represents a function? I mean,
No.
let's say if there are some other values also, -infinity to +infinity, and everything is mapped. Does this represents a function?
No.
Yes, sir.
Yes, sir.
Yes, it
Yes,
represents a
it
function.
represents.
When will it not represent a function is when this element has got two different image. But look at this. This has got only one image, right? And even this has got one image. It's something not happening like this, right? Like this is not having two images like this. You understand? When that happens, then you say this is not a function. This is not a one-to-one function. Agree? This is not one-to-one function, but this represents a function. All of you okay with this concept?
Yes,
Yes, sir.
Okay, fine. So having known that, yes, you have some understanding on this. Let's quickly build on that. What are we going to discuss in today's session? Okay, because we are already lapsed with like 30 minutes. So let me just take up new page and then discuss this. Okay, so what are we really going to do today is we'll see there are so many things that you can learn from what is given in your lectures and all that. One thing is, basically framing an equation and then, finding out the answer. So, well, that is something you will learn with the practice. And I assume that as per the session goes on, you will learn there. What today I can do is I can just summarize you the things. And most importantly, not just summarize, but give you a different approach to, this quadratic function altogether, right? So, my favorite approach is going with the graphs. Okay, so what I believe is, like, if you can visualize any function, it's done. You can do a lot more with that functions. Okay, so that's how I feel. So I can give you that approach and how you can solve that when given a problem. Okay, so now let's see that what we can actually do is, first of all, we know what is this what is a quadratic function, right? So first we can start with this. What is a quadratic function? As we are doing summary, maybe we can just summarize for some times, and then I think I can just wind up this summary thing in 1 hour, and then we can take up some of your doubts if you have any in this week 3. So that's how we can do it. Okay, so summary of week 3 we are doing as of now. So let's give this heading, and then, what is this first, what is this quadratic function altogether? Then, understanding each and every coefficients of it, right? So basically understanding the role of each coefficients. So what are these coefficients? So basically when we write, let's say f of x is equals to ax square plus bx plus c, where these coefficients are this abc. So what are their role when we give this quadratic function? Then what are their role, right? Okay, and then thirdly we can discuss what is this graphings. How do you draw this quadratic equation altogether? So graphing of quadratic function, let's say I'm saying quadratic function here. Then what more we can do with this is, we can maybe discuss some questions. Maybe we'll see if we have more time, but I think we'll have a lot many questions here itself. So graphing of quadratic functions, and then yes, then quadratic functions in vertex form. Okay, this is one thing. Let me anybody know if I'm missing out any point, and then we can actually talk about it. Okay, then there is, this SSC concept which we studied in week 2. Okay, so I hope the concept is clear to all of you, right?
Right, sir.
Yes.
Yes,
So we
sir.
can bring this SSC in quadratic function also. SSC in quadratic function also we can bring in, and you would see that this is not there in your lecture, but these kind of questions will be asked in your quiz. Okay, so maybe we can try to motivate this ourselves, because you see SSC is not restricted to your just straight line. It is beyond that. It can be asked in your quadratic, polynomial, exponential, logarithmic, or anywhere it can be asked, right? So SSC is not just there, because I remember when I was telling you, it's like y minus y cap, right? And this y cap was the model equation. Not necessarily it's a straight line. Okay, it can be anything. So we can just see one example where, this SSC in quadratic function, how does this look like basically, right? So we can just have an idea. Maybe I can take up one quiz question and discuss this. Okay, so this is something we can do. So let's quickly finish this many, but I'm pretty sure that if you can, if you can just learn these many things, you can do at least 80% of the things. 80% of the things means what? Like basically when a quadratic function is there, you can actually dissect that function, and you can know what is what in that. Okay, so that's what I meant. So let's quickly do that part, and I believe this is important, and you can see the lecture videos for more understanding of the concepts on this, and you can solve as many questions you want. Okay, so now for time being, let's just summarize this. So first let's understand what is this quadratic function altogether, right? So you see this, let's say a function f of x. So maybe I can just write this quadratic function as qf. Let's say a function f of x. So you notice this function is basically defined from R to R. right? All real to all real. This is one thing. And this function f of x is given something like this: ax square plus bx plus c. Like this is one of the general form of writing it. Okay. So I hope all of you know this. So having known that, this is the general form. So f of x is equals to ax square plus bx plus c. Why is this function called quadratic? Can anybody tell me? It's because of what do we call this as a quadratic?
X square, sir.
X
X
power
square.
square.
Correct.
So A is not equals to 0.
I'll come to that. But you see this, it's because this you have this x square, because of this only it is called as what? Quadratic. Having, now just imagine, what if a was equal to 0? What it would have happened? It would have happened what? Bx equal to c, right? If it would have been just bx equal to c, what does that represent?
Linear equation.
Line. For that line, what will be the slope be? If this represents a line, then what does the slope be?
B, sir.
B,
And
sir.
what is your y-intercept?
C.
Right? So now you notice that. So essentially, if I have to make sure that this is a quadratic equation, then I have to make sure that a is not equal to 0. Right? Because if a becomes 0, then it's done. This is no more a quadratic. Right? Rest this b equals to 0 or c equals to 0, it does not matter. Right? B can be anything, c can be anything. But a should not be equal to 0. Because the moment it becomes 0, it becomes what? A linear curve. Or maybe a constant function or whatever, right? But it will be no more a quadratic function, right? So this is what we have to understand. This function f of x represents a quadratic function when it is written in this form, that is ax square plus bx plus c. You can write it in any way, but all you have to make sure that the coefficient of x square term is non-zero. Okay. And what does this represent when we write f is from R to R? This R represents what? All of you, could you tell me? What does this R represent?
Real number.
Domain set. This is called as domain set. So what does domain set means? X can take all real values, right? This is what it means. And what is this representing? Range.
Range.
Sorry, not range set, codomain set.
Codomain.
Okay, so this represents a codomain set. And what does this codomain set tells us? That this function, whatever gives the output is the subset of this. So basically, f of x is a subset of codomain set R, which is nothing but your codomain set. All of you okay with this?
Yes, sir.
Any
Yes.
confusion till now?
No.
No,
So
sir.
basically,
No, sir.
this, whenever I write f of x, this is nothing but the output value, right? This is output value, isn't it? This represents output value, because whatever x you put in, whatever the output you get, that output is definitely going to lie in the codomain set, right? Because
sir.
that's what it means. Okay. So then what is the range? Range is basically the set of output this function can take. Okay, that's it. Okay, so this is what the quadratic function is. All of you clear with this?
So the output value is nothing but the range, right, sir?
Yes, the output value is the range. And so all of you understood with that?
Understand.
Okay, so now, okay, so having known these many things, so let's go and understand what does this coefficients, this A, B, and C tells us. Okay, so let's understand this, because you remember when we were doing this, when we were discussing straight line, we actually dissected every coefficients of it. That what is A, like we had this writing, right? Y is equals to mx plus c. So we dissected everything, right? And we understood what does that actually mean, right? Likewise, here we can do the same thing. What does this A tells us? Okay, I think most of you know this, but just for an understanding, that, so maybe I can just draw a table and then I can just explain you these concepts. So maybe I can give a second heading as role of coefficients. And you see what does this coefficients do? Okay, so first of all, understand this. So here I'll just mention coefficient, and then we can just discuss, maybe I can just say this as its role. Okay, and this role is something we can understand from it. Okay, so now look at this part. Maybe I can just shrink a bit. Just a minute. So that I'll have more space for writing. Well, look at this. What happens? What is the role of C basically? So to understand this, note what happens when x is equals to 0. What happens when x is equals to 0?
C.
C fx will be equal to C.
C.
C is
F
also
of
0.
f of
Constant
0 is C. So C is not basically 0 because you see that when you substitute instead of x, you find that f of 0 is basically C. So what does this really tells you? When x is 0, I'm getting C as the output, right? So what does
Yes,
that
sir.
mean? So that means, let's say if I have a curve, something like this. So C is basically what? C is the output value. So when x is 0 here, and this is giving me what? This is C,
Minimum value.
right? So if this function is given ax square plus bx plus c, this C is nothing but what? Y-intercept.
Right.
Okay. So
Yes,
need
sir.
not be like
The
this, but
other end of the parabola is also 0, right, sir?
which other end?
Oh, no, no. Okay, okay. I'm sorry. Yeah.
No
Please
problem.
continue. I'm sorry.
This can also be C, all of you, right? Can this be that C representing thing? It
Yes,
can
sir.
be,
Yes, sir.
because I don't know which is what, right? So I can just say that. Can this also be C?
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
Right? So depending on what are the other coefficient A, B, this is how the curve changes, right? Right? But you notice this C is basically fixed and the C is at 0 only. It's because when x is 0, you see C, you get it here on the y-axis, right? So C is basically the y-intercept. So understand this. No matter what the function is, whatever this constant term in your quadratic function is given, that constant function represents what? Represents what?
Y-intercept.
Y-intercept. Okay. So now let's say if I have an equation, just quickly tell me ax square plus bx. That's it. If I have a function something like this, which among the following graph represents that? Okay. So maybe I can just draw one more graph here. Okay. So you have 5 graphs, let's say 1, 2, and you can number this as 3, 4, 5. So which among all these represents this function?
1
One
and
and
2.
1 and 2. 1 and 2.
1 and 2. Why? Because
1 and 2.
right.
Sir,
Because
y-intercept is 0.
Y is
the
0.
y-intercept is 0.
okay. So now given a function
0.
like this, so if I can give you one example, x square plus let's say 2x, if this is the function, can this represents any of this? The answer is yes, right?
1
Because
and
you
2,
see that
yes.
the C is 0, because if you substitute 0 to this, what do you get output as? 0, right? So it has to pass through origin basically, right? So all of you clear with this?
Yes, sir.
Yes,
Yes,
sir.
sir.
So now we understood the role of C. Now let's go understand the other thing, role of A, right? So role of A is also important. So this A is also called as leading coefficient. So I can just mention it here, and next time we will be using this term only, okay? This leading coefficient. So this is called as leading coefficient. I hope you can see my screen clearly.
Yes, sir.
Sir. So now, yeah, fine. So this A is called as leading coefficient. So let us understand what is this leading coefficient, okay? So now you see this. So I can just write it like this. So leading coefficient, what does this do? Okay. So now notice this, when A is equals to 0, sorry, not 0, it cannot be 0 for it to be a quadratic equation. What happens when A is positive? Or let's say when A is greater than 0. When A is greater than 0, this parabola opens upward. Either it is going to be like this or like, sorry, or like this, whatever, or like this, touching the x-axis at just one point. But notice this parabola opens upward. So if A is positive, parabola opens upward. All of you clear with this?
Yes, sir.
Yes,
Yes,
sir.
sir.
And if A is negative, what will happen? Parabola opens downward.
Downwards.
Okay, so it could be like this, or it can be like this, or it can be something like this. So notice this, when A is positive, what do we see? The parabola opens upward. When A is Lesser than 0, the parabola opens downward. Okay. So what all did we did? We understood what is A and what is C. Now what is left? B, right? So well, specifically you don't have anything functions like B, but B along with something else, it gives us some values. So what is that? Let's see that. Okay. So what does that gives us is something we'll have to notice it here. Okay. So now let's say this. I don't know that, but now I'm not just writing as B, but I'll just give it as role of B with something. So this is something like minus B by 2A. Okay, so this is also called as axis of symmetry. Axis of symmetry. So essentially when the value of x is minus B by 2A, it is told as this is axis of symmetry. But what essentially is axis of symmetry? So I told you in the very beginning that axis of symmetry is it's a vertical line parallel to y-axis. First of all, this you have to keep it in your mind, and that line divides this parabola into two halves. Okay, so all of you okay with this?
Yes, sir.
Okay, so now understand this.
Midpoint of parabola, right?
Mm-hmm. Could you come again? Sorry.
Midpoint of parabola.
Yeah, you can say that midpoint. It's basically not a point though, but what is that? Basically, it represents a line, right? Because axis of symmetry is a line which cuts this parabola into two halves. So this is not a point. Point is something else, that is vertex. We'll come to that vertex part in a while. But as if now this x, when it is minus b by 2a, it represents axis of symmetry, and axis of symmetry, assuming that you know this, do you have any confusion in axis of symmetry? Anybody?
No.
Or you
No,
know
sir.
that? Okay. So having known that, you know that, now what is axis of symmetry? So look at this part. Now we can do lot many things here, but what are those things? So let's understand this. So I can just tabulate this here and note what will happen. Okay. Okay. So now look at these values. Fine. Look at the values of A and B, and we'll look at its nature. Now what happens when A is positive and let's say B is 0? How will the curve look like? And let's say C is 0 for all. Maybe let's not say C is 0, but let's keep something as C. Okay. Now what will happen? Now this was our quadratic equations. So ax square plus a quadratic function, ax square plus bx plus c. What is A? A is 1.
1.
So this is like this. And bx, let's B is 0 now. So B is 0 means
0.
this term is gone. Okay. So and then I'm left with what? C. X square plus c. Okay, so let's say C is something like, let me give it C as fixed value, and let me say that C is 5, or let me not say 5, but let me call it as 2. Let's say C is 2. So what do I get? 2. What will be the graph for this basically?
Will open rightward.
All of, tell me. It's open upward, first of all. And what is the y-intercept?
Upward and
What is the y-intercept?
Y-intercept.
Y-intercept is 2 and it opens upward. So it's going to be something like this. So what is axis of symmetry? Now minus b by 2a, if I have to calculate,
2.
wait. So basically this is not going to be like this. Okay, now you yourself can tell me if I have drawn this graph, prove me that I'm drawing a wrong graph. Okay, so now what is axis of symmetry? If I have to calculate here, minus b by 2a is what?
0.
So that means
0.
this curve cannot represent this because the axis of symmetry is somewhere here, right? So it has to be what? Something like this then. Because I have to make sure that y-axis is the axis of symmetry. And what is the y-intercept value? 2. Right? And A tells that the parabola has to open upward. So this satisfies all the condition, right? So this is that curve which is represented here. All of you clear?
Yes, sir.
yes, sir.
Okay. So this is the graph for this. Fine. I'll just draw the graph for others also, and we can see that. Now let's say A is
Why the parabola opens upwards if A is positive? Is there any reason for it?
because A is 1. A is 1 means what? 1 is greater than 0. So this
Yes.
condition it fits in, right? So because A is positive. If A is positive, then parabola opens upward. This is what we learned here.
No, is there any reason for it why it opens upwards?
Let's simply draw the graph and check. You can simply draw the graph. Maybe you can just take one example. F of x is equals to, let's say, x square plus 1. Okay. And you can take many points. You can take x and f of x value and try to plot that graph. Okay. You will get that the parabola opens upward.
Yeah.
And you can convince yourself. Fine. Is that okay?
Yes, sir.
Okay, so now let's understand this. We'll fix this C, okay? We'll just fix this C. Let C be 2 itself. Now what? Look at this one. A is 1 and B is 1. So you notice this both are positive here, okay? So could you tell me what is this minus B by 2A value? Or let me say B is not 1, but just for the simplicity
By
of
2, minus
calculation.
1 by 2.
Okay,
minus
let me just give it as 2. Let me give it as 2 just for the simplicity in terms of solving this. Okay, so minus B by 2A give me what?
Minus 1.
minus 1.
So it gives me what? Minus 1. So how will the graph look like? Let's understand this. So now, again, this parabola opens upward, right? All of you? Because A is positive.
Yes, sir. Yes, sir.
Okay. And if this is the case, if I have to, if this is the case, what will be my function f of x be? F of x will be what? X square
Plus 2x
2x
plus 2.
plus 2. So this is how the quadratic equation, quadratic function is given to me. So now what? Now look at this. A is positive, so parabola is going to open up, right?
Open up.
And what
Yes,
is
sir.
y-intercept?
2.
Y-intercept is 2. Okay, if that is the case, then something I can think like this. But again, what is my axis of
No.
symmetry?
Minus 1.
Minus 1.
Minus 1, which is going to be somewhere here. That means
Yes,
I
sir,
can
yes,
draw
yes,
this
sir.
parabola something like this, right? So I can say that it can be either like this,
Yes,
and
sir.
saying that this is 2, and parabola. Why am I saying this is 2? Because of this. And why does the parabola opens upward? Because of this.
1.
Why is it the axis of symmetry on the left hand side? Because we were convinced that the axis of symmetry tells us this minus b by 2a, this minus 1 tells you that it is towards the left hand side. But notice this can also happen like this, right? This can also happen like this, isn't it? Huh? Can this happen? Okay, it cannot happen. It's because
No.
C is 2, right?
Yes, sir.
It cannot happen that way because C is 2, right? But it can happen something like this, right?
Yes, sir.
Can it happen or not?
No, sir,
No, sir.
because parabola
no?
should be equal
Yes, sir.
both sides.
No, it is same. Still, if I say this is minus 1, this I have to make sure this was minus 1, no? Here x
Yes,
is equal
sir.
to minus 1.
And in the
Even here
former
also
one, there
x
are
is
no
equals to
roots.
minus 1. What is my C? C is 2. Parabola opens upward.
Yes.
But what is the thing you notice here is, look at my x-intercept. Here x-intercept is what? 0. There is no x-intercept basically. Number of x-intercept is what? 0. And over here, how many, what is your number of x-intercept? 2.
2.
2.
There is something that we still don't have knowledge about in drawing the graph of this quadratic equations. So do you get some kind of motivation that, yeah, what is that? How do we actually get that, right?
Here we can say that the slope becomes constant in the second graph which you have drawn.
Okay, like
Now,
don't go like that because I don't had a space to draw that curve, so don't go in that way. But just understand that this is representing a parabola. Okay?
Okay, sir.
Yes, sir.
Or if you want, I can just draw it in more nicer way. I can say like this, or I can just draw bigger, but I want to, fit this data into this in this pages itself. Of course, there is sharp, and you can say me this is not at all a parabola, but still, just assume that this is a smooth curve and there is no sharp ending, and this is how this is. Okay, you can also have something like this. You can also have something like this. It just touches and it goes back, right? So again, let me say this is 2, the y-intercept is 2, the parabola opens upward, and the axis of symmetry is x is equals to minus 1. Still this
Yes.
satisfies. But look at this, there is one root over here. Root is how much? 1.
1.
Here root is 2, and here no
No
root.
real.
No
See?
root.
No root, no real root. You can say basically we are not talking about the complex root, so forget about that. Okay, so here there is no real root, and here there are 2 roots, and here there is 1 root. So this root thing, if we get to know, then we are done with this, right? We can do many things, isn't it? So what is the next thing that I can have is, now notice this. Of course, we took one example with that thing, and this is the other thing. So we can think of another example where b is being negative. Where b is being what? So if this is positive, let's say this is 1, and this is minus 2, then let's say c is our fixed, that is 2. Then what is your minus b by 2a?
1.
Positive 1.
So if it is 1, that means it's
1.
going to be something like this. Everything is going to be like this, but this axis of symmetry is going to be here. So you can think of something like this, right?
Yes, sir.
This is x equals to 1. And likewise, you can draw for other two, right? All of you clear with this?
Yes, sir.
Okay. So now understand something from here. What is happening here is, look at this. So if I have to just, maybe I can just take the new page and then explain you much better way. Okay. So what we noticed here was, if I have to draw it here in a tabular way, I just want to understand that where does my axis of symmetry lies? Okay. Axis of symmetry, where does it lies? Okay. Maybe I can just write it. I bring it one more column here, and then I can say this is axis of symmetry. Fine. So you just, in terms of AB being positive or negative. Okay. So if A, B minus B by 2. Okay. So now if A is positive and B is negative, what do you get minus B by 2A? Positive or
Positive.
negative?
First quadrant.
Positive. So axis of symmetry is on the right of the y-axis or the left of the y-axis?
Right.
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 So you can just tell me this, whether this is on the right or left. Okay. So you can just tell me this. Okay. So if A is positive again, so well, not positive, but A is negative, or let me say positive only. A is positive and B is positive. Then what about your axis of symmetry?
Negative.
Negative.
It is going to be negative. So it is going to be on the right or the left?
Left.
Left side.
Left. Now if this is negative and this is positive, then what do you get?
Positive.
Positive.
Positive. So is this going to be on the right or the left?
Right.
Right side.
Right. And we are left with one more combination, that is minus and minus. So this will give you what?
Minus.
Negative.
Negative.
Negative. Because you substitute here minus and this
Yes.
will overall
Minus,
make it
minus,
minus. So
minus.
if it is minus, so it is going to be on the right or the left?
Left.
Left.
Left. Okay. So now we got some kind of understanding whether the axis of symmetry is on the left or the right. Okay. So all of us are clear with this?
Yes.
Yes,
Yes,
sir.
sir.
So can we quickly draw the graph for all of these and see how does this happen? So let's see this. Axis of symmetry is on the right, so it can happen like this, right? It
Yes,
can
sir.
happen like this. It can happen like this or whatever, right?
Yes.
Right? Or it can happen like this also, right? Whether C is 0 or not, right? So because I have not mentioned anything about C, but
Yes, sir.
why is it upward? Because C, A is positive,
A is positive.
right? That is why it is positive. And look at this curve, axis of symmetry is always on the right. So given this much information, I can think of some kind of curves like this, right? All of you clear with this?
Yes, sir.
So now I'll just,
Yes.
I'll erase and I'll just redraw the other, and you can also simultaneously work on this and you can draw. So since this is positive again, so now what about this? So this is going to be something like this, because axis of symmetry is on the left. So you see left of the y-axis, or I can say that, you know, this is going to be, in any case, I have to make sure this is on the left, right? So I can still draw this and I can say that, okay, fine. This is what my axis of symmetry is. Axis of symmetry is still here, right? It's on the left. You can have so many combinations like this. But look at this, again, this parabola opens upward. Why?
Because A is positive.
A is positive.
Because A is positive. All of you clear with this?
Yes,
Yes.
sir.
Yes, sir.
Okay.
Yes, sir.
But we still don't know how to get this x-intercept. We'll talk more about this in a while. So, but pay attention with me. Okay. Now A is negative and B is positive. So now what kind of graph do we get? And this is on the right. So can I have the
Right
curve
side.
like this?
No, sir.
Sir, open downward.
Open downward. Okay. So open downward. So I can understand that there are somebody now who are able to understand this. Why open downwards? Because
A
is negative.
Is negative.
or in other words, A is lesser than 0.
A is negative.
Right?
Yes, sir.
And why it is on the right? Because minus B by 2A is nothing but, so this minus B by 2A is nothing but the x value.
X.
This minus B by 2A is this, right? X is equals to minus B by 2A, and you see this is on the right.
Okay.
This x is, when x is minus B by 2A, we get this. Okay, so all of you clear with this now? So you can have many other curves. You can have it this passing through the origin, right?
Yes.
Of course, I should have drawn it more nicer, but you can understand this, right? So
Yes,
this is also understood, and now again this is minus and minus, and this is on the left. So if it is on the left, so both are minus, no worries. So we can just draw it like this, and I can say that yes, fine, this is my curve. And why it is downward? Because A is negative.
A is negative.
And why it is on the left side? Because minus B by 2A. That is, when x is minus B by 2A, we notice that this is happening. All of you okay with this till now? All of you clear?
Yes,
Yes, sir.
Yes, sir.
Anybody who didn't get it? Okay, so if you don't say no, I will assume that you already understood this. Okay. So
Sir,
even
quick
if-
question.
Hmm.
If the axis of symmetry is on the y-axis, then what is the it is left or right, or it is in middle?
Okay, so even that case can happen, but again, you see this. When can that happen? That can only happen when b
B
is
equals to 0.
right? And this can be either positive or negative. So we can take up this case also. Let's take this is positive and this is like this. So could you tell me where is your axis of symmetry? At center?
Y-axis, Y-axis.
So basically at center in the sense what I meant is y-axis. So because we are using left, right, center, so let's use it. When this is negative, this is 0, and what do you get here? 0, 0, right? Well, it's a good question. So now you can tell me where is it? Still on the center. Well, can we just draw the graph for this?
Yeah, upward.
Open upward or axis open downward. Upward
It can be either like this. No, sorry.
No,
It can be like this.
it is second.
It can even be like this. Hmm?
Yes, sir.
Okay. But you see the axis of symmetry is
No, sir, no. Y-intercept. No, sorry. Okay.
It can be. It can be.
Yes,
Because
it can
you
be.
don't know about x-intercept. You don't have
You said A is
information.
negative, even as A is negative, sir.
Sir,
A
A
is
is negative and B is 0.
B is 0. You wrote it as A is negative and B.
A is negative and B is 0. Yeah, that what is wrong in this?
So the parabola
Sir,
upward
negative.
direction downwards. So,
I'm talking about this one. I'm just talking about this case.
yeah.
Yes, sir.
Now I'm coming to this case. For this, same thing, but again, parabola will be downward or something like this. Or if you want, you can bring in one more saying that, yeah, it just touches the x-axis, right? So now you can see this. So maybe this table is slightly important for you guys for your own learning. So you can just make a note of this or just take a photo. Now I'll just erase this part.
Sir, one more question.
Yeah.
So far we are understanding B with relation to A. So
Yeah.
what is B alone represents?
B alone represent. What does B alone represents? So see, because you see this, B alone itself has no roles, but it has got roles with the other coefficients. See, B alone, you cannot just say anything, because if you have this curve, see, B can either take up the value, B alone, if you are to ask me, then I can just tell you that fix A and then talk about B. Like fix A and then talk about B, then you will understand, okay, what is the role of B. Let's say if B is 1, okay, and if you have a quadratic equation, f of x is equals to ax square, so basically x square plus bx plus c. Okay, so B can be anything, either it can be positive or negative or 0, right? It can either be positive or negative or 0. So these are the three cases that you can come up with.
Yes, sir.
And then you can make an understanding what is the role of B. So to understand the role of B, you have to fix A and then C. Okay, clear?
Okay, sir.
Yeah. So having known that, we got some idea about the parabola opens upward or downward, whether on the left side or on the right side, and what is the y-intercept. But we don't know what is x-intercept still, right? So now let's talk about the x-intercept. Fine. So I'll just erase this part, and I can talk more about this. So look at this. What about the x-intercept? So now basically, let me tell you that we were talking, this is how we started our tabular column, right? And here this was our coefficients, and this was representing our something nature or whatever. So how was this? So coefficient, and what is this telling about? So basically there is one D, and this D is called as discriminant. Okay, and this discriminant is not for quadratic function, but it is for quadratic equation. That means our f of x is equated to something. Let's say f of x is equated to 0. Okay, because you don't talk the concept of discriminant for a function, but it's a concept of a quadratic equation, because it's an equation. It can be 0 or anything, but it is equated to some values. Okay, so discriminant concept come from there. Okay, so now what is this D basically? So this D is nothing but B square minus
4AC.
Okay, and this tells us that how many x intercept it has. Okay, so this will tell us what? I can just write down this. D tells us that how many, make a note of this, it tells how many distinct real roots are there. Okay, distinct. You can of course understand it in other way and say that, okay, why are you saying distinct real roots? We can also say that it is giving us complex root, but we will not talk about this. It's the same thing, it's just an understanding. If it is not real, then it is complex, right? So I'm just taking you in this aspect and then explaining you. D tells us that how many distinct real roots are there for quadratic equation. So it's no more quadratic function, but quadratic equation. Okay. So now you understood this. So
Sir, I'm sorry to interrupt you. I did not get the discriminant explanation. I'm sorry.
okay, I'm just in the part of explaining it. So don't worry, you will understand this. I'll be at it. Okay. So this D is basically let's say this is something called discriminant, and it is given as b square minus 4ac. So let's quickly tell me what is D for this. Okay. So if I have an equation something like this, x square plus 2x plus 3. What is D for this? Can somebody quickly solve and tell me what is D for this? So this is going to be 4
minus 8.
Minus 8.
So if I have to solve this, so this is going to be 2 square minus 4. What is a value? 1. And what is c value? 3. So if I have to solve this, what do I get? 4 minus 4 3 is 12. And this is going to be minus 8. So what is discriminant value? Is it positive, negative, or 0? What is this?
Negative and negative.
So this is how you get discriminant value. Well, this was just to give you an idea that how do you actually get this discriminant value. So we understood that how we get from given an equation, how do we get it, right? So now see this. If this is the discriminant, then what is this? Am I really talking about this? So make a note of all this. When D is positive, so when D is positive, so basically I'll just make a note of this here. When D is positive, okay, then nature of roots. So basically I can just give it as roots. So what happens here? So roots means basically x-intercept. Understand this. Okay. I hope this is no confusion here. When I say root, it tells us x-intercept. So when x is positive, or let me say if D is greater, okay, I can, okay, fine. Let me say it as D is positive and negative and 0. So when D is positive, okay, then so there are two distinct real roots. Distinct real roots. Okay. When D is negative, there is basically no real root. Okay. When no real root means, I'll tell you what is this basically if you are not able to. When D is 0, you have one distinct real root. Okay. So what does this really mean? So now understand this. So now two distinct real roots means what? Basically there are two x-intercepts, right? So I can have curve like this. Look at this. How many? This is, let's say, minus 2 and this is 2. So these are two real roots, right? Are they real? Yes, they are real. Are they distinct? Distinct means what? Are they unique? Yes, they are, right? So distinct means this is minus 2 and 2. This is distinct, right? All of you clear with this?
Yes, sir.
Yes, sir.
Okay.
Yes,
so now
sir.
you can also have curve like this. You can have something like this as well, right? Or you can something have anywhere like, you know, left, right, or whatever, but it can be open, upward, downward, or whatever, right? But all I meant to say is there are two distinct real roots. Okay. Now what about these things? There is no real root. Now for this, let me just give you example like this only and keep it as such. When do you say there are no real roots? Basically
When
there
it
is
will
no
not cut
x-intercept.
x-axis.
When there is no x-intercepts, right? So what kind of curve can you think of where it is not touching? I can think of like this. It is not touching the x-axis at all. Right?
Sir.
Or
Yes, sir.
I
Yes,
can
sir.
think of something like this. It is not touching the x-axis at all, right?
Yes, sir.
So basically there is no real root.
Yes, sir.
Right?
Got it.
Okay. Now when do you say there is one distinct real root? Now look at this curve. When it just touches the x-axis.
Yes, sir.
One point of curve.
Just it is touching at how many places? One. Right? So one distinct real root, right? So there is one distinct real root, or it can even be downward, right? It can even be downward like this. It is just touching and coming back. So there is just one real root, right? right? All of you clear
Yes, sir.
with
Yes,
this?
sir. Yes.
Yes,
This
sir. Got it.
D tells us
Yes,
that.
sir.
So what does this D tells you? When you find out this D value, and how do you get the D value? Minus B square by 4AC, right? Okay. So all of you
Okay.
understood this part. Now let me check how many of you understood this. Okay. So to do this, I will just simply draw a curve and I will ask you its values. Okay. And then I can understand that how many of you understood. Okay. So now let's say I have a curve like this. You can start solving by yourself, and I think you shall be able to answer this. Oh, just a minute. Okay, so let me tell you this. This is -3. This is 5. Okay, so yes, only this many informations I have, and let me say this is 2. Okay, now could you tell me what is D value? D is positive or negative?
Positive.
Positive, sir.
Positive.
Positive.
Discriminant D is
Positive.
Positive, sir.
positive. Okay, so positive means okay. How many?
Two real
What
roots.
are the x
Just
Two
intercepts?
real
Could you tell me
roots.
what are the x intercepts for this?
3 and 5.
minus
Minus 3 and 5. Minus
Minus
3 and 5.
and 5.
The x intercepts are basically
Minus 3 and
3
5.
and 5.
Minus 3 and 5.
Okay, what is y intercepts?
2, sir. 2.
2, sir.
Y intercept is
2.
2. Okay, so all of you can say this y intercept is 2. Fine. Okay, and
Yes.
what is axis of symmetry?
Axis of symmetry will
Right side.
be in the right side, yes.
In
Right side. Okay, but could you tell me the
Positive,
exact
positive
value?
x.
Could you tell me the exact value?
Minus x equals to a.
X is equals to 4, I can say. Because you see, if this is 5 and this is 3 units away, right? Then what is half of this?
4.
4. So this is, if that is 4, so that means x is 4. Well, it is not going to be 4, but I'm so sorry. I
X
wrote
is
it
1.
wrong. It's going to be 1,
yes.
right? Because this is going to be at the center of this only, no? No matter what. Even if I take this part, it is going to be at center of this. Even if I take a bigger part like this, it is still going to be the center at that, right?
Yes,
So
sir.
I hope you
Yes, sir.
understood, right?
Yes, sir. Yes.
Axis of symmetry is not 4 here, which I miss.
Sir, could you explain axis of symmetry once
Correct,
again?
correct. I'll tell you.
Sir, it's the same, right? Like when you said x equals to 4, that means we can take the 4, four parts from the -3. So
Right,
it's
right.
actually 1. So
But what am I claiming here is x equal to 4, which is wrong, right? I cannot say x equal to 4
No,
is
no,
wrong.
no. Yeah, that is wrong. Yeah.
Yeah. So, but again, what you told is right. As you are taking, when you are calculating, so basically, if this is your, if you can see this, how many units are there altogether? 8 units. Just take it in a something, because if this is 5 units and this
Distance
is 3,
between
so
2 bits.
altogether
Yes, sir.
8 units. So axis of symmetry will be half of it, which is going to be 4 unit.
Yes, sir.
Yes.
Right? This is going to be 4 unit, which is something like this. If this is going to be 4 unit,
And 5
so,
minus 4 equals to 1.
so from here to here it is 3 unit, and I just have to take one more unit here. That will make it 4 unit, right? So if I take 1 unit, that means x is going to be equals to what? 1.
1.
So axis of symmetry is what? 1.
1.
All of you understood?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
So fine. So now we understood just from the graph, my axis of symmetry is what, right? Now could you
Yes,
tell me, now let's do more with this. What is A? A is positive or negative?
Negative, sir. Negative.
Negative.
A is negative. What about
Discriminant is positively, please explain.
how discriminant is positive? Because you see, we just made an understanding here. Look at this. Look at this curve now. Now we are just thinking it this way. I was telling you earlier like this, but now you have to think it in the opposite way. When do you get 2 real roots? This is the question. When do you get 2 real roots? When discriminant is what?
Positive.
You understand this?
Okay, sir.
Is it clear now?
Yeah.
So when do you get 2 real roots? When discriminant is positive, right? So now you see this A is negative. From this curve I can say, what about C? What is C value? Could you tell me?
2.
right? This is essentially y-intercept, so I can just simply write down here, or c is equals to 2, okay? And a is positive. I don't know what is the value of that, but still, and a is negative. And we also got to know that minus b by 2a is what?
Equals to positive. One is
Something I got,
Positive.
right?
Positive.
Okay. So now I have the roots. Basically, I have
Is
the
1
roots.
comma, oh sorry.
So now you
That
see
is
that I can do
vertex.
so many things when just the curve is given to me, right? So if I can give you any curve, you can definitely tell me what is A, B, and C, right?
Yes, sir. Yes, sir.
Right? Now, could you tell me whether this B is going to be positive or negative? Now, if I have to draw a curve like this, ax square plus bx plus c, so I can quickly say that c is what? C is 2. A is something I don't know the exact value, right? But could you tell me whether B is positive or negative from this?
Negative.
Positive, sir.
Positive.
So this I can write it as
Positive,
minus b by 2a. So this is going to be 2a. And since a is negative, so let me say this is negative. So negative times negative will make it what? Positive. So this b is going to be minus, b is equal to 2a. So I can simply say that this is a square plus 2ax plus 2,
Plus 2.
right?
Yes.
Okay. Now this is something we got to know. And all of these are in what? All of these are in what form?
Sir, A is in negative, right?
A is negative. That is why this B turns out to be positive. Because when you substitute this
you
negative
haven't-
here, this minus minus get cancelled.
But you haven't marked that minus A square.
Sorry, I didn't get you.
So
The equation
f
that
of
you
x
Okay,
is
the
equal
equation I
to
did not
minus
mention
of
it.
A minus
Okay,
x square minus
okay, that is
ax square.
understood. No, that is understood because A is negative. I say that A is negative. So when I substitute the value of A, I'll give it as a negative.
Okay.
Okay. So maybe if that's the case, then I should mention it like this. Fine. We can just give it as, because since you are telling it in that way, and here B, if B is negative, then it turns out to be negative. So I can just give this as minus 2ax. This makes sense?
Yes, sir.
Or maybe I can just give it as positive here and give it as negative here. This will also make sense.
Yeah.
Okay, this makes sense.
Yes, sir.
Okay, then how do we get the value of AB? How do you get the value of A? Could anybody tell me? How do we get the value of A?
Sir, from
By dividing
discriminant
B
we
by
can
2.
By discriminant formula b square minus 4ac, we just replace the b value and we have c already equals to 2.
Well, that will become more difficult because if there is like b square minus 4ac, my calculation will be more. So what I'll do is I'll not go with that part. I'll just quickly take this. What is f of 0?
2.
2, sir. 2.
F of 0 is 2. Okay, fine. Sorry,
Two.
I meant to say basically I made it wrong here. So what is f? When is this thing happening? F of
minus 3
x
and
is
5.
equals to 0. So when is
Minus
this happening?
3 or
3 and
5.
comma
3 or 5. So let me take it as 5. Okay, so I can say that f of 5 is 0.
Yes, sir. Yes,
Right?
sir.
So I can substitute this in this equation, particular equation.
Yeah.
Right? So if I substitute this, so what do I get? F of 5 is equals to 0. So that means minus 5 x square. And this is going to make it what?
10
Sorry.
10
So it's 25.
25.
So it's going to
Minus
be
25.
The making
correct.
answer.
So it's going to be minus 25
Minus 25. A
plus
10a
10a
and A plus 2.
is equal to 0. Now could you tell me?
Yes, sir.
So this is going to be minus 15a
Minus
is
15a.
2 is equals to 0, or a is equals to
2 upon 15. 2 upon 15.
Okay, so now I can just simply substitute this here and this minus, let it be as it is. So 2 upon 15 x square plus 2 upon 15. So this is going to be 4 upon
4 upon
15
15x.
x plus 2, and we know that b was positive, so we can see this b is positive, and we knew that a was negative, so this is negative, right? So we can just reconfirm. So this is what the equation of this polynomial, this quadratic function f of x is, right?
Even sir, by directly we can say that vertex, we can find that vertex also, right?
You can find the
While
vertex
looking
value.
at graph.
You can do that as well. Okay, so now
Why did you choose only 5, not minus 3?
1 comma
you
2.
can choose that also. You will still get the same equation. You can choose -3 also, you will still get the same equation. You will get the A value Sm. You can just try that also. Okay. Okay, so fine. Let's move to the next concept. And I think we are discussing a lot many concepts, and it's already like not 1 hour, but I'm still left with 10 minutes for 1 hour. So you see this. So we discussed so many concepts, and I hope most of the things are clear. And see, if there are so many concepts, naturally you will understand it. But how do you keep it with you? How do you how does that become, this concept becomes your concept? So how do you actually take that is because of practice. Okay. So you have to do a lot many practice in order to understand this or just, to be more thorough with these concepts. Okay. So see, we talked about so many things. Now, if I give you any quadratic equations, you can do lot many things with that, right? So I drew a graph and then I asked you to find out the equation here. Now what, I'll give you an equation and then I'll ask you to tell me the graph for this. Okay. So this is going to be x square plus 4x plus 5. Simple. Okay.
Yes,
So if
sir.
this is the equation, how do we get the graph? Okay. So now let's quickly see, without finding anything, let us just understand what is the values. Okay. First of all, my C is 5. Well, something it's going to be here. A is positive.
A is
Okay.
positive.
A is positive. I get to know that also. Axis of symmetry is what? Minus b by 2a. So could you tell me what is minus b by 2a?
4.
Minus 4 upon 2, which is
Minus
going to be minus 2. That means
Yes.
this is something going to be something like this.
Yes.
Okay. It is something going to be something like this or like this. And how do we understand this one? I need to know discriminant, right? So what is my discriminant value?
-4.
Minus.
So it is going to be b square minus 4ac, right? So b square minus 4ac is nothing but what? This is 16 minus 4. A and c is nothing but 20. So this is going to be what?
-4.
So this is going to be -4. That means d is lesser
No
than
real roots.
no real roots. So basically it
real
is not going to touch the x-axis at all, right? And what did we get axis of symmetry? I just
4. -4, sir.
it was
-2. X equals 2.
And this is nothing but y-intercept is 5. So this is going to be, my curve is going to be something like this. Okay, maybe not like that, but like this. Right?
Yes.
So how did we find that, what the height is, that vertex point?
This vertex point, I'll come to this. So that was what I was trying to give you a motivation here. I'll come to this. At what height it is, we'll understand this. Well, that is something we can understand. Now look at this.
Sir, one question.
Yes.
If suppose equation is like x square plus 4x minus 5, then it will come under in a down, like on the y-axis. It takes the -5 as a y-intercept. X square minus plus 4x minus 5.
X square
Plus 4x minus 5.
Okay, -5. Okay, fine. Okay, so now you just have to do what? Same thing. If it is -5 and this is like 4, and all you have to do is just check your discriminant.
36.
36. So this is going to be 36.
It's positive. 2 distinct
This is
roots.
positive, so this is going to be yes. And this is -5, so it's going to be here -5. And it is positive, that means it has got 2 roots, basically, right? And again, the axis of symmetry is still the same, right?
Yes.
So it's going to be something like this, right? It's going to be something like this. Well, this is what, like most importantly, that's how it's going to be. But I'll come to this part. Maybe first, let me the thing where I was trying to bring you. Somebody asked me, okay, what is this? How much height is this? That is what something we wanted to find out. We know that axis of symmetry is what? -4. You can just simply substitute it here. F of -4 is what? So that you get to know what is the other part of this, right? So what do you get when f is -4? So this is going to be what? 14, 16.
16.
And this is going to be?
-16.
This is going to be -16 plus 5. So
Plus
this is going
5.
to be 5. Well, there is a
5.
mistake then. I think.
Yeah, that's what I
Sorry to
thought.
interrupt you, sir. Isn't the axis of symmetry -2 here?
Yeah, it is -4.
Okay, so that's what something we were, something we were doing.
Yeah.
So axis of symmetry, I erased it. Somebody told me the axis of symmetry was -4, so I took that as. So if this is -2, and then now you can put at -2 here. Okay, so when this is -2, then this is 4.
4.
-8 plus 5,
Plus 5.
which will give you what? -4 plus 1. This is going to be 1. So this is basically, this point is nothing but minus 2 comma 1, right? And this point is called as vertex.
Yes, sir. May I ask one question? Yeah, so is it just like that, like minus b by 2a upon, and that we have to substitute that value,
Correct,
minus
correct,
b by
correct.
2 value in a
Correct, correct.
equation, then we will get that x and
Correct.
y coordinates of.
So vertex is of this form, minus b by 2a, comma, f of minus b by 2a. Now it makes sense?
Yeah.
What does this represent? X-axis. And this represent, basically not x-axis, but x.
Coordinate
And
x
represents
coordinate
what?
and y coordinate.
And y coordinate.
Yeah.
Okay. So now you got it. So vertex is of this form. Okay,
Yes.
clear? All of you okay with this?
I have a
Yes, sir.
question.
Yes.
When our discriminant is like -4, so does it represent something in graph, or is it only for our knowledge that it won't touch x-axis?
Okay, so this discriminant is something we actually use for finding out what are the roots for this. Okay, so
Oh, that's all.
yeah, that's it. And also it tells us graphically whether it has got some x-intercepts or not. So you see this.
Yeah,
when-
like what you have told, that's all. Like whatever
Yeah,
value
that's it.
comes.
That's it.
Okay, that's
So let's say when you have been given an equation f of, so now you see this is one concept, make a note of this. This is something vertex, okay? And vertex is given like this. So if a parabola opens upward, the vertex, the y coordinate of the vertex represents the minimum value or the maximum value?
Minimum.
Minimum value.
Minimum value.
values.
What is the range of this function f of x?
Natural. So 1 to infinity.
1 to infinity, yes.
1 to infinity.
Yes, sir. One
Range
to
for this
infinity.
is
Uh,
1 to
One to
infinity. And
infinity.
1 is included or not? Yes.
Yes.
Yes, I
Closed.
included.
Closed.
Right, so understand this. So range for this is 1 to infinity. So this vertex, when if it opens upward, the vertex represents the minimum value, or the y coordinate of the vertex represents the minimum value. And when the parabola opens downward, look at this, when parabola opens downward, what does this vertex represents? The y coordinate of the vertex
Maximum.
represents the maximum value. Okay,
Maximum.
make a note of this. This is something you should understand.
Yeah,
So why are we even talking about this minimum and maximum? Because we will motivate ourselves more when we are talking about in the calculus. Okay. So, but for time being, you can be asked questions like this in your thing also, like in your qualifier as well. Okay, this is minimum, this is maximum. If this represents a minimum, so then that should click in your mind that okay, basically my parabola opens upward, and then you can think of your A will be definitely positive in that case. Okay, we will not tell you positive, negative, but this is one information by which you can understand, right? So it is all about visualization. When something it is told, make a graph of it. Just think of it. What is this question telling you? What does this graph look like? Once you can just visualize the graph, your problem is solved. You don't really have to solve this particular question at all. You can just do lot many things with the graph. Okay. Okay, so one more thing is, so we understood this is one more concept, this is vertex concept. We understood what is this vertex, okay? I did not take it in a very elaborative way, but I just told you what is this vertex, okay? Well, now I'll just give you one more concept, and I can talk about the roots for this. So there are two things which I would like to discuss. How do we get the roots for this, or basically how do we get the x-intercept? Because discriminant D was telling us how many roots are there, but how do we get the exact roots? Well, this is one concept that we'll learn. And the other thing is called as quadratic equation, or basically quadratic equation in vertex form. Okay, so how do you represent a quadratic equation in a vertex form? Okay, so these are the two things. First, this roots thing. So maybe I can just write down here, or maybe I just take the next page and explain you. So this, look at this roots of f of x. Let's say our f of x is x square plus dx plus c equals to 0. So again, this root concept is basically when it is equated with something. Okay, equated with something means it's not a quadratic function, but it's a quadratic equation. So roots of quadratic equation f of x equals to 0 is nothing but something like this. Okay, so now how do you get the root? So there are two ways of finding. Basically, there are at least in our course we are telling two ways. So how do you get it? One is by factorization method, and the other thing is by formula method. Okay, so I will just quickly write down what is this formula method, and then I'll come to this factorization. So formula method, can anybody tell me what is the formula?
X equal to
minus b plus minus
minus B
So
plus
x equals
minus
to
and
minus
the
b
root
B
discriminant
plus
plus
minus
over minus root over of d.
root B,
yes
yes, sir,
discriminant
upon
Because
2A.
d is what?
B square
discriminant
minus
Minus
4x.
4x,
minus 4.
right? So this is how we are
yes
getting d. Now just imagine if d was negative here. So root over of negative is what?
Complex root number.
Complex
Complex
number.
root. And that is why we were telling, there is no real root when d was negative.
Yes, sir.
Understand?
yes sir.
Okay. So now having known that, you understood. So formula method gives us this, and from this we can actually get out what are the roots. So maybe I can just take one quick example and then discuss what are these things. Okay. So now if I have f of x is equals to x square, could somebody tell me any equation? X square minus 5x plus 4. Somebody told me at that time, right? So now let us put this formula method into this. First, let me find out what is d. How many roots are there for this? So could you tell me?
Minus
So d formula is here.
5
So
25
I squared, so 25 minus 4. A value is 1 and C is what? 4. So
4
4
9.
is 16. So
16
25 minus 16
9
is nothing but
9.
9. So
9.
D is 9. Okay. So
and
now
then the
what?
root of 9
This is
is
greater than
3
0. That means there are two roots. Two
yes
real roots, right? Then what are those real roots? That is something we can get with the formula method. So x is equals to minus b. So what is minus b value for me?
5
Minus 5.
Minus 4.
Plus or minus root over of d is what? 9 divided
9.
by 2a.
which is 3
So which is, wait, this is 2. So,
1
so this will give you 3. So eventually minus into minus will make it plus. Plus or
Plus
minus 3 by 2.
8 by
And
2
essentially I can write this
4
as what? X can be either 5 plus 3 by 2 or 5 minus 3 by
minus
2,
3 by
which
2.
will eventually give me what? 5 plus 3, 8. So
4 or
2
1
comma
or
2
1.
or 1
4 or 1.
1
sorry
1.
1.
So these
1
are the
1
two roots that I get.
Yes, sir.
Okay. So now you see that now I got the exact x-intercept for this. So if this equation was given to me, I know that my y-intercept is 4, discriminant is 2, and this parabola opens upward, and I know the axis of symmetry is going to be what? So well, over here you don't even have to think what is your axis of symmetry, because that will eventually fit in this root. If this is 1 and this is 4, and parabola opens upward, and it has to touch these two things, so it has to go like this. So axis of symmetry, could you tell me, somebody, what is axis of symmetry for this?
2.5
5 by 2, 5 by 2, 2.5.
2.5
Just a minute.
Difference is 3. It will be
So how many
5.
units are here? 3 units.
3.
3
3 units means it's nothing but if you take
1.5.
half of it, it's going to be 1.5 unit, right?
yeah
So
so
if this
2.5
is okay, if 1.5 units, so it's 1 plus 1.5 units. So this
Yes, sir.
x is going to be
2.5.
what? X is going to be what? 2.5.
2.5.
2.5.
yeah
So 2.5 is your axis of symmetry, right?
yes
So when this was positive. So now you understood? Okay, so we understood with the formula method that my roots are what? With formula methods, we got as 4 or 1, right? So we got it. 4 or 1, what? It's like basically 1 and 4, not or. Basically, you have both here. All it
1
meant to say,
and
why did I say
yes
this or is basically your f of x will be 0 at any of these two values. That is why this or is given. But this is actually and because we are finding out x-intercept. Now let's go with the factorization method, and we were using this formula. I mean, so I can just erase the other part. So if I just erase the other thing and just see what is with the formula factorization method we get. So in factorization method, you think of this way. Okay. I think all of you know this, but still this is
yes
like
sir
a high school thing, but still what you do is this into this, you write it like this, 4x square. Okay. Now you will have to think of what are the products of these two things.
that will give
Basically, if I have to factorize this,
minus
I
5
have to think of that what should be the factors of this. I mean, what are the factors of this such that when I add those two factors, I get this.
2x. 4 and 1.
So if I have
4
to
and
think
1
of this way, so if I have to take this 4x,
Minus 4x.
1x.
so minus 4x and
Minus 1x.
minus x. So
minus
if
1
I
x
multiply these two, so definitely this is a factor of 4x square, because when you do this product of this, what do you
It
get?
will be 4x square.
So it will be 4x square. So
4x
definitely
square.
this is what? This is a factor of this, right? And I told you, you have to choose your factors in such a way that when you add these two factors, you should get this middle term, right? So now clearly
Yes,
when
sir.
you add these two things, I get this middle term. So how do you get this? X square minus 4x
Minus 4x
minus
minus
x
6
plus
plus
4.
4.
So essentially I can write this in this way. Now what I can do is
We take
I can
common
just take
x.
out x common from here. So I'll just take out x common and then I'll get
X
what?
minus 4.
4.
So essentially what am I doing? I'm finding out the roots for this. So that means what is this? F of x will be 0 at that point, right? So I'm
Yes, sir.
equating it
Yes.
with the 0, right? So that's what we are doing. And now x minus 4 I write like this. And now what?
Minus
I
1.
can simply, no, I can just simply write x minus 4 blindly here. And now I'll
Yes,
think
sir.
out what I can think from here that, you know, it'll make it this. So if I take
Minus
out minus 1 common, then it will suffice my need, right? So now
equals
look
to
at
0.
this. Now from this, x minus 4 and x minus 4 are common, right? So I can take out this common root from here, right?
Yes, sir.
And then what I'll be left with?
X minus 1.
Minus
X
1.
minus.
So I'll be left with x minus 1. And again, this has to be equated to 0 because this is 0. So when do you think this will be equal to 0? When either
When
x
the
is
X
equal
X
to
minus
0.
4 equals to 0.
0.
So essentially this is to be written, when will this be equals to 0? When either x minus 4 is
Minus 4
equals to
equals to
0
0
or
or x
x
minus 1
minus
equals
1
to
is
0.
equals to
Minus
0.
1
So
unequal to
equals
x
to
is
0.
0.
equals to 4 or x is equals to 1. So this
Yes.
is the route we got with the factorization method, and we also got it with the with the
Formula
formula
method.
method, and with the factorization method also we got the same thing. Okay. So now you might be thinking, those who are like, let's say you lost your touch with finding the factorization and all this thing. It appears it is tough because you might be thinking, first of all, I have to find out the factors for this, and then I have to add them, and you know, to make sure that this is the middle term. Well, you know, for most of the cases, you will find that this is the easiest way, factorization method, than the formula method. Okay. So you can practice as many things you want, because that depends on how much you are exposed to this, right? Let's say if you had a 10 to 15 years of gap in your normal, like, since you don't deal with these things in your daily life, right? So let's say if you're not dealing with this anymore, since your domain is different or something else, right? And you're not dealing with this mathematical formulas, something like this, then you will have to give some practice, at least do some practice of finding the roots for at least, you know, 10 questions or something like that. Okay, take up some random quadratic equation and find its root. Okay, well, that is something I would say. Well, this was not the whole thing, because you know, this is very basic and that is something we don't even teach here. Well, but still, I told you like how to get the roots for this. Now, having known this, how to get the roots, I told you that there was one more concept which was missing, which I didn't tell you, which is discriminant. When I was telling you, not discriminant, but the vertex, right? I told you that this represents the vertex. Well, this is not parabola. This represents the vertex, right? This part represents the vertex, and vertex is given by the formula minus b by 2a, comma f of minus b by 2a, right? Let's say my f of x was nothing but ax square plus bx plus c. Okay. Now you notice one thing. Basically, what happens in your exam or somewhere, you will be given a vertex, right? You will be given a vertex like, let's say, 5 comma 4. Okay, and you are asked to find out what is a quadratic equation. Well, there is one way of doing it, but you know, I can just simply tell you equation of, or maybe, yeah, let me say it as equation of quadratic equation in vertex form, or maybe not, say quadratic function in vertex form. Okay, so how do you get this? So over here, let's say your vertex are h comma k. So I'm saying your vertex is h comma k. Then how do you get this? So the formula is y minus k is equals to a times x minus h. What the formula is? Okay, where a is what? A is your leading coefficient.
Leading coefficient.
Okay, so now let's just convince ourselves, why am I even claiming this? Okay, so now let's just take some examples. Okay, so now look at this. Y minus k is equals to a times x minus h. Okay, so now let's say my vertex is given as 4 comma 5 and my leading coefficient a is 1. Okay, so now if this is the case, then how do I get the equation? So as per my formula, I can say that y minus 5 times x minus Go ahead. X minus 4. This implies y is equal. Sorry, there is something I missed out. I think there is some square, right?
It is a
Square
lit.
term. X minus h the whole square. Yes. So this is how it's going to be. So this is going to be x minus 4 the whole square. So this can be written as x minus 4 the whole square plus 5. Okay. So this is how basically you get the equation of this quadratic function. Okay. So you can try to convince yourself, and maybe I can just expand this further and we can just see that if this is the vertex or not. Okay, so we can do this. So let's quickly do that. So if I have to expand this, could you tell me what will be the expansion be? X square.
X square plus 16 minus 8x plus
X
5.
square plus 16
Plus 16 minus 8x
plus
Minus 8x plus 11.
6, yeah,
plus 5.
plus 5.
Plus 5, if I have to add it, this will give me 21. Okay.
Yes, sir.
Okay. So now could you tell me what is my axis of symmetry for this? Minus b by 2a. We are just reconfirming whether this is giving me that value or not. Okay. So what is minus b by 2a?
4.
So this is going to be so this is going to be 8 by 2, which is going to be 4. Well, this part is confirmed. Now let us look at, since this is 4, so I can just simply put this 4 into this. So if I have to put this 4, so what do I get? 4 square minus 8 times 4 is nothing but
32 plus 21
plus 21. So 4 square is nothing but 16. So if I have to do this, then what do I
16
get?
plus 21 equals to 5.
So what do you get? So 21 plus 16 is what? 37.
57.
No, sir, no,
37
minus 16.
Minus, sir.
Okay, yeah, got it.
37 minus 32.
Minus 32, yes, sir.
31 minus 16.
So that means this formula is basically right. This is what I wanted to tell you, that don't trust me blindly. You know, I can do some error, you know, because even I'm human, right? So I can do some error. So essentially we proved that our formula can be written like this and we can get our answers. Okay.
Yes, sir.
Fine. So
Yes, sir,
all
fine,
of us
yes.
are clear with these many concepts. Now let's quickly go back and see, did we miss out any concept, as we promised in the beginning that, you know, these are the certain things we were going to discuss. Okay. So we discussed this, what is quadratic function, then understanding the role of each coefficient. I hope I was able to convey you what it was and you understood.
Yes, sir.
Then graphings of quadratic functions, we saw it. Yes, how to do that. There is a lot more to do with this. Basically, when you go to polynomial, when you learn the graphings of a polynomial, so polynomial, you know, right, it can be of this form. Let's say you have given a polynomial x minus 1, x minus 2, 3 the whole to the power of 3, x minus 8 the whole to the power of, let's say, 11. If this kind of polynomial is given, how do you draw the graph of this? Well, when you learn this thing, then if I'm taking any session, I will come back and tell you, okay, how do you actually draw the graphings of a quadratic function just by the rules. Well, as of now, whatever I have told you, it's very easy. I mean, it's all very smooth, and you have learned almost 90% of it. Okay, like the graphing parts of it. So, well, there is some missing gap which I would like to trace it when I'm discussing graphings of a polynomial and all that, and then I'll trace you back. Okay, like, yeah, this is also the way of thinking it. So you will get a different realization that, yeah, okay, this is what it is, right? You will get a different sort of realization. Well, as if now, whatever is needed for graphings of a polynomial in your week 3, it's more than enough. And I think I have dissected it in all the ways possible. Okay, and then we also discussed quadratic functions in a vertex form.
Vertex.
Yeah. And then there is something called SSE in quadratic functions. Well, I leave it to you whether you want me to discuss this concept or pick up your doubts. What do you want?
No, sir, please discuss this concept.
Discuss, sir.
So let's discuss.
Let's discuss this concept.
Yes,
Yeah.
sir.
Yes, it's one.
And do any of you have any doubt? If it is, then I should prioritize that basically. If you have any of you have doubts.
I have doubt in question activity question 3.5 question.
Sir, actually I have doubt in week 2 graded.
Okay. Well, if you have a doubt in week 2 graded, I would suggest that wait for a graded solution to come, and then you can, you know, see that solution and get it convinced. Okay. So, any of you have doubt anywhere else?
Sir, activity question 3.5 question number 2.
Okay, so I'll take up that questions, because you see, I should give time for that as well. So this SSE in quadratic function is something I'm leaving now. Then. Okay.
One question. Who will take the tomorrow session of math in the morning?
Not sure who will be taking, but I'm not taking for sure. Somebody else will be there.
Okay, sir.
Yeah.
Sir,
So let
sir, please explain maximum and minimum once again.
concept of maxima and minima. Okay, so it's very simple. Now you just see this. If this is upward, what do you think? This is minimum value or the maximum value?
Maximum value.
Maximum value.
Minimum.
Value. Maximum value is here, no?
Minimum value.
This is minimum value.
Okay,
That means if parabola opens upward, the vertex, the y coordinate of the vertex represents the minimum value. Okay. And if parabola opens downward, what happens? This is the maximum or the minimum value?
Maximum value.
Maximum value.
Maximum.
This is the maximum, and the least value you can have is anything, right? Okay, so clear with this? So this concept is something I'm leaving it for time being, and we can see if somebody else discuss this or not. I mean, or you yourself can give emphasis to this. And there are some questions by which I don't think so. It's like very big thing. A small touch was needed, but still, I'll take up these doubts. Like somebody was telling, they have doubt in this activity, right?
Excuse me, sir.
Yes.
You explained maximum and minimum, right? So, is that necessary to make that coordinates? Then only we can say that it is maximum.
No, it's not necessary.
Only by vertex we can say, right?
Yes.
Okay.
By vertex, you can understand this. All you have to do is just, when you want to find out the minimum or the maximum value, all you have to do is minus b by 2a, f of minus b by 2a. This will give you the least or the most value, right? Right? It can give you either the least or the most value, depending on what is the coefficient of a. Okay, so a quick question. If a is positive, okay, what does this gives you? F of minus b by 2a. Does this gives you the least value or the most value?
Minimum.
Least
Least value. And if a is minus 1, what does this give you?
Max value.
Maximum value.
Why some of you, if somebody did not get why these people are actually able to tell it, is because look at this. If a is positive, parabola opens upward. If opens upward, then y coordinates of the vertex represent what? Least value. Okay, that is how they were able to tell it. How they were able to tell it? Because they were able to visualize the graph. Okay, so that's how it is. So those who are still struggling with visualizing the graph, please watch this video. Maybe you can just re-watch this, and you can. I think there is nothing more that needed for visualization here. Okay.
Yes,
It's
sir.
all the same concept that you can think it in other way. Okay. So now let me quickly go to that particular question. What somebody asked me.
So 3.5.
3.5. 3.5. Which question?
Last question.
Last question. Okay, this one, right? Okay,
yes,
fine. So a football player, maybe I can just take a photo of it. Just this, and then I can discuss this. One more thing, you see, if some of you would have submitted the graded assignment of week 3, let's say, okay, I request you to resubmit those assignments because there are some corrections that is been made, okay. Some correction in terms of like there was some 1 point instead of 1 point, it was written as 2 point, or like say 3 point or 0 point. Well, that is one correction, and there is one more correction, a small correction was mentioned. I think that will be sent as an announcement today. But all of you can, if you have already submitted week 3 graded assignment, I request you to resubmit it. Okay.
Hello, sir.
Yes.
So I want to make a point, sir. So here, I think there's something wrong with the second option, activity question 3.5.
This one only, no? This particular.
Yeah.
Okay, so let's see that what is error, and then we can rectify that. First of all, look at this. A football player kicks a football from the ground. A path of the football can be modeled by the function this thing. Okay. So now first let me just draw the graph for this, right? That should be our main strategy. So first of all, look at this. There is no B term. So if there is no B term, that indicates what? Basically, what does that indicate? What is my axis of symmetry?
Y-axis.
Y-axis, right? So because it has to be on the center, right? So if that is the case, then yes. And does this parabola opens upward or downward?
Downward.
And axis of symmetry is somewhere here. Just a minute. So it is going to be something like this, right? So now what more is given? Y-intercept is 2. Basically, this is 2. 20. So this height is 20 altogether, right?
Yes, sir.
What more do I want from this? All I can do is find out the roots, the other roots that I can do, right? So if I have to find out what are these values essentially, right? So how do I get this? So I can do this. When do I get this? When h of x is 0, right? When do you think this is 0? So when I rewrite this, once x square plus 20 is equals to 0, or I can say that x square is equals to 20 into 125, right? I can do this. I can do
25.
this, right?
Yes, sir.
So what do I get from here? So
25.
125 into 2 is what?
250.
2500. X will be plus or minus 50.
So 250, yeah. So this is something I get. So x is nothing but what?
Yes, sir. Yes, sir.
So this is going to be plus or minus 5, right? So plus or minus 50.
50,
So
sir.
this is going to be minus 50 and this is going to be 50. Okay. What do you notice? How many units are this? There is like 100 units.
100
This
is.
entire. Okay. Now let's discuss what is being asked here. So clearly my h of x is, let me just write down here so that we can just make a note of this. So h of x is given as what? H of x is minus 125 x square plus 20, right? So this is what my h of x is. Now the distance between the two players is 90 feet. Okay, I didn't read the question properly. Just a minute. A football player kicks. All I did is just saw this equation and I did this, right? Now let me do more about this. The path of the football can be modeled by the function this, where x is a horizontal distance, h of x is the height. So well, this is. Can both you mute yourself or wait? I'll just unmute myself. Mute on. Okay, so now where x represents the horizontal distance, so this is basically x and this is h of x, and the height of the football above the ground. When both are measured in feet, okay, another player jumps and takes the header when the slope of the function is this thing, right? Okay, so there was one more concept I wanted to tell you. Slope of your function f of x. So slope of your function, basically if it is in this form, quadratic function ax square plus bx plus c, this is given, slope of a function is given as what? 2ax plus b. So this will give you the slope.
Yes, sir.
For a straight line y is equals to mx plus c, it was very clear that this represents a slope. But for quadratic equation, how do you get the slope? This is the equation. This expression gives you the slope value. Okay, so all of you clear? Make a note of this, that this gives me the slope value. Okay, so if having known this, so now they are saying that when slope is basically when 2ax plus b is minus 6.4, the another player jumps and takes the header. So maybe let's say some values over there, and this is being negative. So of course over here at all these places the slope is positive, right? So definitely the other player is somewhere this side, right? Assuming that he is somewhere here. He takes the header from here. All right. You can think of it, right? How I told that this is going to be somewhere here.
Yes.
Okay. So over here B is 0. A is what? So this is 0. So I can just
Can you
remove
explain that, please?
B is 1 minus 1 upon 125.
Somebody asked me something like, what explanation you need? Joy, please go ahead.
Yeah, how was the other person in the right hand side? I mean, in the positive part of the graph.
It's because you see the slope is negative. Okay. Now just try drawing the slope over this point. How does the slope look like? Like this?
Yeah.
Like this? So does this slope represent a positive value or the negative value at this point?
Positive.
So if you have doubt in that, let me just tell you. Let's say if this is a line, what is the slope of this line? Positive or negative?
Positive.
Positive.
It's always going to be positive. Now look at this. What is the slope of this line? Positive, but the slope is higher than this. For this, the slope is greater, right? For this line. Likewise, if I have to draw over here, again the slope is positive, but the slope value is lesser than this curve basically. Okay, so this is all positive though. If I have to draw all of this, the slope value is positive. And if I have to draw this curve, now look at this value.
Yes, I got it.
Right?
Yeah.
So this is going to be negative. So if I have to draw anywhere over here, the slope, it's going to be something like this, something like this, something like this, and over here it will become 0 at this point. And then it start decreasing. The slope will start decreasing. So since it is given a negative slope for me, then I can think of that the person is not standing here, but he is standing somewhere here on this side, on the positive x side, positive x-axis side. Right? Clear now?
Yes, sir.
Clear or still have doubt? Clear?
No, sir. Yes, sir.
Okay. So now let's find out at what value this slope is this. Okay. So now first of all, b is 0, right? We all know that b is 0, and from here, I know that x is given as what? Minus 125. Sorry, a is given as 125. So I can just simply substitute that value, and I can write this minus 2 125x is equals to minus 0.64. So if I can just cut these two things and I simplify this, what do I get? Can somebody tell me? Please use your calculator and tell me.
X is equal to 40.
X is equal to 40. Is it? All of you please confirm this because I am not sure.
Minus 2 is 60.
So this is where the person is standing. This is where the person is standing, right? All of you clear with this?
40.62, sir.
40.62.
Yeah.
That's
625.
Just 40.
40, sir. It's 40.
Just 40, right? So you can just cross check with others and see what it is, right? Okay, so x is 40 here. So now you can see that this, if x is 40, then what is this y value? If this is x, then what is this y value? Can you tell me?
7.2.
How much do you get?
No,
7.2.
7.2 you get. So all you have to do is just put it here and get the value. Okay. So now the maximum height reached by the player's head to take the header is, first of all, this person is standing where? At x equals to 40, and he is taking a header, right? So his maximum height is what? 7.2 feet. Well, this is right or wrong?
True.
True. The distance between the two players. Okay. Another player
No,
comes and
sir.
takes the function.
It's
Okay.
100.
It's 100, right? So this is incorrect. The maximum height reached by the player's head
Wrong,
to take
sir.
the header is
The
9.2
difference
meters.
between the two people is 90 feet, no, sir? Minus
No,
50 and up
it's
to 40.
So minus
50 is 90.
Yes, you're right. Because this one player is shooting from here and another player is taking header from here. So this is 40 and this is 50 units. So altogether the
It
distance
would be
is
90.
Thanks for bringing that. Thanks for correcting me. The maximum height achieved by the ball is 20 feet. Is this right?
This is right.
Yes, sir.
Okay. So how many options do we get correct here? Three
Three
options. So we can just check that if that is right or wrong.
So
So
what?
we got this. Let me just check this and then we can discuss. Okay, so what? Yes, that is right.
So what that 100 is then?
What this 100 is?
Yeah.
So it is nothing to do with this.
Like
Basically, if this header was not taken, then the ball which is taking this path would have fallen here.
Okay.
Yeah. So I could have given one more option if that second if the person could not take header, and you'd say the goal post was at that place, then is that a
like
goal or
ground to
not or
ground,
something?
we can say it is 100.
Yes.
Okay.
Okay, so now it's clear to all of you,
Yeah.
and
Yes,
there is no problem with that options, right? Okay, then I think we can wind up now, right? Because we discussed many concepts, and if I'll discuss more, it will be difficult to grasp. Or if you guys want, I can discuss this SSC also because I am willing to teach. Are you willing to learn?
Yes.
Yes.
Sir, I have a
course.
question.
Yes, sir.
Okay, you have a question? Yes, tell me.
Sir, activity 3.4, question number first.
Well, this is activity session, so I have to prioritize this. So I'm sorry to others. Which one? Activity which?
3.4.
3.4.
Yes, sir.
And which question? First question.
First.
Okay, now you tell me what is the answer for this.
Very much similar to that.
Just think of it. It's like now you can visualize everything. This is like very easy. I mean, let me not say and say it as a very easy problem, but think of it, what it is.
But sir, after explaining, like you explained very well all the concepts.
So now I
it
think
is
you
quite
can
easy.
just try re-attempting this, okay? Or whatever the concept I have told, you can just do this. Or do you really want me to solve this? I can do that as well, but I think
No,
you should
sir.
give a try to this because we discussed one similar problem and we have done many things with this. Okay, so just think of it like how can you do it. Yeah, just give it a try, and if you still don't get it, just put it in the forum or or Discord anywhere. We can just take it there. Okay. So shall we discuss one SSC thing?
Yeah, sure. Sir.
Because even I should feel that I have thought everything and I'm I'm done with that part. So those who want to leave can leave. There is no problem. You can see it afterwards, and if you want me to, I can just explain you that concept. It's a
Hello,
small
sir.
concept. Yes.
Hello, sir.
Yes, please tell me.
Sir, I have a problem, sir. Lecture 3.3.
What is the problem?
Sir, please play the video minute 3.
Okay, just a minute. I'll do that. First, let me think of, yes, here I have that. You cannot see my screen, right? Okay, just a minute.
You haven't shared, sir. Now it is visible.
Which one? Lecture 3, right?
Yes, sir.
Tell me.
Sir, about 3 minutes.
Just a minute, I'll open that. About 3 minutes. Okay. Okay, so basically, the thing what sir is trying to do here is he is trying to, find out what is this slope basically. Okay.
Yes, sir. Yes, sir. Sir, my doubt is by I minus by I minus 1. Sir, how it is filled?
How it is what?
Oh, sir, minus 3 in column by I minus 1. How minus 3 minus 1 1 1 1 3?
Okay, so basically look at this part. What is y? Okay, 4. I don't know what point sir has taken. What is what here? What is yi sir is taking here?
Sorry, sir.
Yi is 1 here, right? So yi is 1, and then
Yi
yi minus 1 is something this sir has taken, right? Yes, that's what it is. So this is yi. So you can see my cursor, right? So this is your yi. Okay. This point, you can
It's
see my
1
cursor.
minus 4, sir. It's 1 minus 4, previous value.
The previous value?
Sorry.
I didn't
So in
get
the
it.
second column, yi, so
So yi is 1 in second
yeah,
column, you can see.
yeah,
He's talking
and
about the second row.
I minus 1 is 4. So 1 minus 4 is minus 3.
Okay, yeah, fine, got it. Correct. So this is how you are saying. So this is
Yeah,
the preceding
exactly.
value is yi minus 1. So this is how he is getting. So 1 minus 4 is minus 3. Okay, clear?
But why we are doing so? This why I
I'll tell you.
minus.
Basically, sir, all he wants to prove from here is how do you get the slope of a quadratic function? Well, see, there are different ways of deriving at this conclusion. Okay, one way is telling that okay, what sir is telling you, he is basically trying to reduce the slope, and he is coming to that conclusion that yeah, this is what the slope is. Other way of understanding is through the calculus part, which is in week 7. You can understand why is this slope this thing. Okay, well, these are the two things. So even if you don't get it here, for time being, what you can do is just understand what is the slope formula and go ahead and learn that concept. Because I think that is the most right concept to learn this slope concept actually, I would say. In calculus part, what you will do. But here, it's just a motivation to give you an idea that how is this straight line concept coming up to give you the slope of this quadratic function. Okay? Is that okay?
Okay.
Even if you don't get it, it's okay, no problem. But do learn this, that how is this slope equals to 0? Because once you know the calculus, I think it becomes very easy for you. Okay, so I'm sorry, I can just share you my screen again and give you one example where these things are happening. So quickly pay attention to what I'll say now, and we can just try to this will take me another 5 to 10 minutes, and I can just tell you what is that.
It's already 9:12.
Yeah, I know we are already late, but we also started late, I would say. So I'm sorry, but just learn it. If you want to leave, you can leave, but this is something.
No, sir. Like you also have
Okay.
to do lots of work. So
Correct,
that's
correct. I understand. But yeah, but this is also important that, I'll tell you that what it is. Now, see, this question, this particular question is a quiz level question. Okay, this was asked in a quiz, in some quiz. So now you see this is not very easy thing. We thought you SSC in second week, but the SSC is been asked in the third week. So the question is, so let me just zoom this. A well-educated carpenter is asked to carve out a wooden block in the shape of a parabola. This thing, where k is an integer constant. Refer this. She has asked to carve out in such a way that such a way that the curve p of x can be best fitted according to the given table. Okay. So over here, all I know is if it is best fitted, then what I have to think of.
SSC should be minimum.
Correct. So I have to think of SSC, and in SSC I have to find out y minus y cap the whole square, right? Equation I equals 1 to how many entries are there? 4. So this is 4 I can give it here, right? So this is what it is, right? So if I have to minimize this, what should I be doing here? I should be finding out what is this SSC value. So how do you get this? So how do you get the SSC value?
13.
So first is go ahead and tell me, because what is my yi cap? First of all, tell me what is this y cap? Y cap is x minus 2, x minus 4 plus k.
That
Right?
equation, sir.
Correct. So now you just have to tell me, tabulate this and tell me what is the value, and then we can discuss this more. So first I can just find out my y cap value also. Okay, so and this is y and this is x. Okay, so let me first tell me what is my x value. 1, 2,
13.
6.
Okay.
Right? And what is y value?
13, 10, 9, 8, 18.
18. Right? So now tell me what is y cap value when x is 1. When x is 1, what do I get? So this is going to be minus 1 and minus 3. So this will make it what? 3. Right? So this is going to be 3 plus k. So this is going to be 3 plus k. And when I substitute 2 over here, what do I get? Just k.
K.
Right? And when I substitute 3 over here, again, what do I get?
1, minus 3 plus k.
So this is going to be minus 3 plus k, right?
Yes.
So minus 3 plus k. Is that right?
3.
So this
Yes,
from
yes.
here, I get it 3. If I substitute over here, I get it 1. And over
6
here, if
plus
I
k.
substitute, just check this. If I substitute 3 over here, and this is minus 4, this I'll
It's
be
minus 1 plus k.
minus 1 plus k. So that is,
Sorry.
no problem. Minus 1 plus k. Okay, so I get this. And when I substitute this 6, what do I get?
6 by k. 6 plus k. Sorry.
Wait, we can just check this
8
out.
plus
So,
k.
so from
Wait,
here I
wait.
get 4, and from here I
Okay,
get it 2. So
God.
it is a 8. Okay,
8
no
plus
problem.
k.
8
plus
plus
k. Okay. So now what do? We do this, right? Y minus y I cap the whole square. So we can just do this. So observe this. This is your given value, or
yi.
so what do you call this value as? Given
Yn.
value. Let's say this is given value, and
Given
this is
value.
predicted value.
Predicted value.
Yes.
Right? So this is what we find out the difference, right? So y minus y cap the whole square is something I'm going to find out here. Okay. So what do I get? Y cap.
10 plus
If I have to substitute over here, and then I put this here, what do I get? 10 minus k the whole square. Right? And from here I get what? 10 minus k the whole square again.
y
Right?
minus, sir.
Yeah, it's because you see this is 13
Okay.
minus, right?
Okay.
What is this value?
3
plus k, and when you, and this is whole
Yeah.
square, so when you do this will go minus over here, so that's how you get it. Okay, so now you see this, and next what do I get from here?
8 minus k.
10
Is it going to be 8 or 10 again? It is going to be 10
Sorry.
minus k.
10 minus
K the whole square, and over from here also I get 10 minus k the whole square. Okay,
Yes.
so now what do you notice from here
All
is,
the values are same.
so it's okay. So now what SSC will tell you, what sum of all of these. So sum of all of these is what? This is 1, 2, 3, 4.
4
So I can say
times.
that
4
4
into
times
10
minus the whole square. Okay, now I have to minimize this SSC. Okay, now if I have to minimize this SSC, what do you think? Where do you think that is going to be minimum?
Sir,
Or
k
what value
equals
of
to
k it is
10.
going to be minimum?
K should be 0,
K
then
equals
it
to
will
10,
be
sir.
0.
Okay, so now what I can do is I can simply do this is just expand this. So what do I get? X square minus 20x minus 20k plus 100, right? And then I can simply put this here. So 4k square minus 4 to the 8. So this is going to be 80k and this is going to be 400.
400.
Okay. So now look at this part. Parabola, is it opening upward or downward? Upward.
Upward.
So this will give me minimum value at where? At vertex, right?
Yes.
At vertex. For what value of k I'll get the minimum value?
10.
So k is going to be minus b by 2a. That is where I'll get the minimum value, right?
Which is
So minus b by 2a will give you what? Minus 40. So this will be 80.
Minus
80
2.
by 2 to the 8. So this is going to be 10. So when
10.
k is 10, I get the minimum SSE value. All of you clear with this?
Yes,
When
sir.
k is, so I can just write down, when k is equal to 10, I get minimum SSE. Because that's the least SSE value I can get, right? All of you clear with this?
Yes.
Yes, sir.
Okay. So now come to this part. Now what are the questions they're asking? Okay. So from the above information, what is the value of k? So now we got this value of k. And why do we get this? Because they are telling it. P of x can be best fitted according to the given data. So now you're doing the best fitting value. So when do you think the best fitting value is? When SSE is minimum. And SSE is minimum where? When
K
k
is
is 10.
10.
Okay. So now from that information, I got k value is this. Now look at this part. Using the above information, what will be the height of the wooden block? What will be the height of the wooden block? Now notice this. This is what the carved out portions of a wood, right? And what is the height of this wooden block? This h, right? All of you clear with this?
Is that this is the maximum value, I guess.
Wait, well, this is the
No.
height. No, this is the height of this wooden block,
Yeah.
Yes, sir.
right? And this carved out portion was something p of x. This is my p of x,
Yes, sir.
right? This is my p of x, x minus 2 plus x minus 4 plus k is what? 10, right? So now if this is my quadratic function and assuming that this is your 0, 0, think this as 0, 0, okay? What is this basically? This is touching and going something like that, right? So if I have to find out this height, if I can just get out what is this height, that is what essentially we are doing, right? So now we can simply expand this and see x square minus
X square
from here
minus
6x plus
6x
8
plus
plus
18
10. So I get what? X square minus 6x
plus
plus
18.
18. So this 18 is nothing but my y-intercept.
Intersection.
Yes.
Yes,
This
sir.
is nothing but 18. So this height is going to be what? 18, and that is how you get 18. Okay. So you see this is a quiz level question. Here how many concepts were there? How many concepts were there? First of all, you should know what is SSE. You must know something with the graphics. Like I told you, right? The vertex, upward, downward. At least that information you should have. And secondly, you also had to get this B information. And this B information was with some understanding the real world problem. Thinking that, okay, if this is my curve P of X, this is nothing but always giving me y-intercept. But again, this was also important that you visualize that this is your origin. Right? So how do you get all these things is by practice. Okay. So this is all I wanted to tell you for this. So you see this, there are concept and here SSE was used. Okay. All of you clear with this? So you can practice more and more questions. And I think with whatever concept we have learned today, we shall be able to do most of the questions in your practice graded and even in your quiz. All that you have to do is just revise this concept and do problems, okay? And I think it's not going to be very difficult once you know the concept very well, okay? So fine, we can end our session now.
Hello,
Yes,
sir.
sir.
Yes,
So, are the tutorials very important?
very important, very important.
Okay.
Tutorial videos, all tutorial videos of anything is very important. Okay, so do watch them. So even if you don't watch, okay, I should not say that, it's a wrong thing to say. But still,
You are about to say the videos, right?
so but I'm telling you, like, you can just watch the videos or you can just go through the slides, but tutorial is very important. Okay, because you have many concepts in that, you know. Basically, they'll teach you how to solve a problem, and those problems are not easy problems, right? So this is all from Swarnam. You want to say something?
Hello, sir.
Yes, good
Yes.
morning, sir.
Yeah.
So many videos I'm not able to see the ones which are happening, the activity sessions and all the all these videos are not available in the website. How do I access, sir? In
It's
case
not
I miss.
available in the website, but it's there in your calendar.
Oh,
Even
so
in the
you can go to the
YouTube
calendar
also.
and access the videos
Correct,
which are
correct,
like
correct,
over.
correct. You will see the YouTube link there. You can get
Okay,
it from
sir.
it.
Thank you. Thank you, sir.
Hello, sir.
Yeah.
Sir, what is quiz?
Sorry, what?
What is quiz? Quiz.
What is quiz? Oh, okay. Basically,
Graded assignment.
no. A quiz is what I meant is like your qualifier exam.
Oh, same, sir. Qualifier exam is a quiz.
Yeah, that's what I meant. Because you see, there are two students here, so two types. Basically, one is like the fresh students who is going to write the qualifier exam, and the
Yes.
other students who is already in the program who have qualified the qualifier, and they are doing
Two,
this
sir.
course. Yeah. Okay.
Yes, sir.
So all right, then we can just wind our session, and it's already
Sir, I
9:30.
have a doubt.
Sir, 1 minute.
The
Yes.
YouTube videos, sir. Sir, will every
You
time
can
the
get it in
value
the calendar. Sorry, what?
Sir, every time the value of yi minus y
Sir,
hat I square will be same, like in the previous question.
Not every time. It's not every time. In that particular question, it's like that. Okay. So
Okay, sir.
do not generalize it.
Sir, should the qualified students also write quiz one?
So basically, if you qualify your qualifier exam, your qualifier exam is basically quiz one. Then it will be considered as quiz one.
So we don't need to write the quiz one. Right?
So basically, your qualifier itself is quiz one.
Oh.
Yeah. If you qualify, then it becomes a quiz one. If you don't, then it's not a quiz one.
But the syllabus is same.
Yes.
Sir,
From
quiz
3.2
1
to
and quiz 2 will be compulsory for
It's not
gradation.
mandatory. It's quiz one, or if you're a term student, then quiz one or quiz two, any of this. But we take best of this, any of them, right?
In case we don't attempt quiz 2, then it's fine, right? Like if
Oh, that's fine.
that is
But make sure that you score good marks here, because 20% of weightage is given here. And see, there are two formulas for calculating your final grade. One is like we take up your quiz one score. If you have just written one quiz, any of the quiz, we consider any one of the quiz and give you the thing. And if you have written both the quizzes, then we have a different formula for calculating it. Both are actually same, but all
where
I
we
meant
can
to say is
find
it's
that.
good that where do you find that? It's given in the
I
handbook.
have gone through in a handbook. It's not there.
Basically, if you want the grade S, so you have to
Yeah,
write
but
the both.
quite a complex formula is in place for calculating the flexibility.
Sorry, what?
Sir, actually, it is there in the handbook, but I couldn't get how they are calculating the scores even.
Okay, fine. So you can just re-talk between your friends and tell me, or you can just come any of this open house session. We can, sorry, office hour session. We can tell you how it is.
Thank you, sir.
Okay, fine. We can just send our session now. Thank you all.
Which open hour sessions are you available?
Okay, in my case, I'm not. So well, we cannot tell that. You can.
So, but
Even
will we
in
make week 4
the study
conceptual
sessions,
thing?
we can ask all these questions.
Let me see if I'll be assigned or not. If I'll assign, then definitely I'm going to take it.
So can we put the request that it get assigned to you?
Yes,
Fine,
sir.
we can see that. Yeah.
We always will.
Okay.
Thank you.
Thank you all.
Thank you, sir.
Yes.
Thank you, sir.
Bye.